Take a look at these three paragraphs. I've just asked a question to a few different variations of Llama 3.1 using Ollama. The question was, describe a black hole in a single paragraph. What do you notice is different about these three answers? Can you figure out which one is from an FP16 variant versus a 2-bit quantization? Is it obvious? Welcome back to the Ollama course. This is a free course available here on this YouTube channel that'll teach you everything you need to know about how to use Ollama to run artificial intelligence models locally on your laptop, on your computer, or even on an instance that you own up in the cloud. So far in this course, we've mostly covered how to use the basic functionality of Ollama and how to find models. In this lesson, we're going to look at what the different quantizations available are for most models and then compare them. If you look at the Discord for Ollama, you're going to find lots of people that say that 4-bit quantization of any model is useless. There may be times where a 4-bit quantization of a model isn't as useful as larger versions of that same model, but in most cases, it's probably going to be more than adequate for most of your needs. But I don't want you to take my word for it. I'd like to show you how the different quantization options perform for the same model. To do this, I created a simple program that lets you pick a model that you've downloaded and then enter in a prompt. Then it will try that prompt for each of the quantizations of that model that you've downloaded. It's also worth noting that most times you ask something of a model, you may get a different answer. So if you're trying to assess any model, you really should ask the same question multiple times. In my tool, I'm asking 5 times for each quant, but there's a variable near the top where you can change it. You can find the code for this program if you visit my repo on GitHub. That's github.com/technoevangelist. Then look for the video projects repo. In there, you should find 2024-08-20 quant tester. I use bun to run this, and you can find the setup procedure at bun.sh. Bun is a super fast runtime and ecosystem for TypeScript. To run this, you should grab a few quantization variants of the model you want to try. So I'm using Llama 3.1, so visit ollama.com/library/llama 3.1. Then click on tags. We want the 8B instruct model, so I'll start with the Q2_K quant. Click the link, then you'll find the command to run it. Copy that. Now paste that into the terminal. Optionally, you can change run to pull or just quit out of Ollama when it's done downloading. Then do the same for the Q4 and FP16 and any other quants you want to try. If you already have the models, you should regularly repull the models to get the latest versions. I use the fish shell on a Mac, so I run this command every now and then, which lists the Ollama models, grabs the names, passes that to an echo command, and then pulls that model. I used one of the models to generate that command, so if it doesn't work for you, paste the command into the prompt for a model and tell it that this works on fish shell on a Mac, but you have bash on Arch, or whatever you have, and it'll probably output the fix. Let's start with my example from the beginning. And here were the 3 answers that I highlighted. One was generated in about 2 seconds, another in 3, and another in 10. The 2-second answer used a 2-bit quantization. It feels like pure magic that even works. The 3-second answer used a 4-bit quantization, and the 10-second answer used the 16-bit floating point weights. Which is which? Is one of the answers 5 times better than the other? Or 3 times better to justify the time? Sure, 10 seconds isn't a lot of time, but if you ask the model a lot of questions, then that time adds up. Maybe with all 3 of them shown and with a tag displayed next to them, I could justify that the FP16 model gave a better answer, but just looking at the text without a label, I doubt anyone could say that the Q2 model is a Q2 model. I would say that all the answers are equally valid in different ways. And if I could only use one question to judge which model to use, I would always go with the fastest one. Now, how about if we change our prompt to the classic logic problem about 3 killers in a room? It's a terrible question to judge models with because models suck at this. It's like giving a model a math equation and expecting it to answer. Use Wolfram for that. Stick to the stuff that models are really good at and are designed for. But in this case, the FP16 model did marginally better than the Q4 model, which was a lot better than Q2. And I tried both questions with the 70B model too. For the black hole question, if you put any of the answers in front of anyone, I doubt anyone would be able to tell which was a 70B model versus 8B, and which was Q2, and which was FP16. But for the logic puzzle, Q2 got it right every single time, and Q4 got it right 60% of the time. I don't have enough memory to try FP16 for the 70B parameter model, so I don't know how that performed. There are some who will say that you need higher quants for function calling. There will be a future video in this course about function and tool calling. I have a few videos already on this topic elsewhere on this channel, but for the course, I want to stick to just facts and less snarky opinion. So for this video, I'm just going to stick to the simpler version of the facts. But essentially, at a high level, function calling is just about outputting as JSON so that your application can use the results from the model with a function in your app. You can call that function a tool if you like. Variations include being able to provide a list of tools and the inputs they require, and having the model choose the tool and output the proper JSON for that tool. Ollama recently announced support for tool calling, but it also announced support for tool calling 8 months earlier. Essentially, there are two different procedures for tool calling. They don't really have names, so let's just say there's an old way and there's a new way. I would love to say the new way is better, but it simply isn't, at least not yet. I don't doubt that it will be in the future, but that future isn't here, not yet. The new way requires you to provide the schema for the tools you want to run using a specific format that is somewhat documented. It also requires you to use specific models that are fine-tuned for function and tool calling. When you follow the procedure, the Ollama API will then inject your schema for your tools into the prompt and feed that to the model. Unfortunately, this fine-tuning seems to require, in most cases, using the higher parameter models at a larger quantization to get more consistent success. But depending on the model, success rates are still often only 60% to 90% when asking the same question multiple times. The old way is left up to you to define the schema in the prompt yourself, and this can be confusing. But with a little practice, it becomes pretty easy. Ideally, you provide the schema, set the format to be JSON in the API call, and provide an example. When those are set, it's pretty hard to get it to fail until you go to very small models like the 3 billion parameter variant of Phi-3. I tried this with my test runner. There's a check in there that looks for the word JSON in the prompt and switches over to using format JSON. This isn't ideal, but makes things easier for testing. The Q2 quant got it perfect, and 1 out of 5 tries failed for both Q4 and for FP16. I wouldn't have expected Q2 to run better in this test, but I would imagine that if I had more tries for each, the success rate for both Q4 and FP16 would go up. Someone suggested that there was noticeable degradation when it comes to reasoning. Here's another example that requires a bit more of that. A train travels 60 miles in 90 minutes. At the same speed, how long would it take the train to travel 100 miles? The correct answer is 150 minutes or 2.5 hours. Q2 answered it correctly 3 out of 5 times, and both Q4 and FP16 answered correctly every time. I would think the next logical question you have is something along the lines of noting that those questions aren't the questions you would ask. You may think they are stupid questions. I don't know your questions, and neither do the benchmarks. There are plenty of benchmarks that will claim one model is better than another, but you really need to ask your own questions to these models to figure out which one provides the best answers for you and which quantization tends to work for your questions. I think in general, you should always tend to use the smallest parameter size and smallest quantization that gives you consistently good results in most cases. The idea of waiting minutes extra for a marginally better answer is ridiculous in most cases. Use a tool like the one I created for this video, or there are several others as well that are more polished. They'll help you judge answers from different variations of models. The important lesson here isn't that these are the right questions to ask, but rather that you need to ask the questions that you tend to ask, and you need to judge what works for you. Oh, and always pull the latest version of the model and Ollama to ensure you have the best environment to test. Thanks so much for watching this video in the course, and I hope you have a great time making AI part of your life using Ollama. Goodbye.